Hello friends, how are you? Welcome to my channel Civil Globe. I am Santosh. Today I am going to model the house using ETABS 2017. This is the first video of the tutorial series of the ETABS. Now friends, let's know about the ETABS. ETABS is the building software which stands for the Extended Three-Dimensional Analysis of Building System. Now guys, let's open the ETABS first. Go to ETABS icon and click on it. It takes some time to open. ETABS has mainly three parts. First is modeling, second is analysis, and third is design part. Here I am discussing the modeling part. This is the first video and rest will be discussed in my upcoming videos. Here I mainly model the house in the ETABS. Modeling consists of defining materials, defining section, defining diaphragm, defining load patterns, defining mass source, assigning supports, assigning load, assigning diaphragm, defining and assigning the mesh, defining the load combination. In analysis part, we analyze the bending moment diagram, shear force diagram, reaction, deflection, response spectrum plot, and center of gravity and center of stiffness. In design part, we will calculate the area of the reinforcement in beam column. Now friends, go to file and click on new model. Then dialog box is opened. Then go to use built-in setting with, then display unit is taken as metric SI, and steel section database is Indian. Steel design code is IS 800 and 2007. Concrete design code is IS 456. And then click on OK. Here new dialog box is open. Then friends, go to simple story data. Here I have the building which has number of stories 4. Typical story height is 3 meter. Bottom story height is 3 meter. Here bottom story height you may change, but I take this data here. Then go to custom grid spacing, not the uniform grid spacing. Then go to edit grid data. Then friends, let's open the AutoCAD files here. Here is my building which has spacing data are available. Okay, this is the building which I am going to model. Okay, then go to display grid data as a spacing. Here go to AutoCAD file and first spacing is 10 feet 6 inch and second spacing is 12 feet 6 inch in X direction. Okay, let's edit it. 10 feet 6 inch, enter, and 12 feet 6 inch, enter. ETABS automatically converts the data into meter. This is 0 and D grid is deleted, and go to Y grid data. Again, let's open the AutoCAD file. First spacing is 10 feet 1 inch, 10 feet 1 inch, enter. Next spacing is 11 feet 6 inch, 11 feet 6 inch. Next data is 11 feet 4 inch. Okay, and remaining is 0. You may change the bubble size here to 1000 and click on OK, and click here grid only and click on OK. Here two windows has opened. First is plan view and next is 3D view. Here grid is made. Let's close the model explorer. Now the second part is defining the materials. For that, go to define and click on material properties. Then click on add new material. Then let's take on region is India. Material type is concrete. Standard Indian. Grade M20. M20 is basically used for beam and slab. Click on OK. Here it is the default values which is kept as it is. Don't do anything here. Click on OK and add new material and define the M25 grade concrete. M25 is used for column. Click on OK. Then all data is default here, so click on OK. Then again go to add new material. Then we have to define the rebar here. Standard Indian and HYST grade 500. 500 grade is used for longitudinal rebar. Click on OK. This data is default data. Don't do anything here. Click on OK. Friends, again add new material. Rest data is same and define the HYST grade 415 which is used for shear reinforcement. Click on OK. And the rest data is default data here. HYST means high yield strength deform bar. Then click on OK. Then click on OK. Now friends, let's define the section properties. For that, go to define and click on section properties. Then go to frame section. Okay. Now first of all, we have to delete this value. Go to delete multiple properties and select all of these and delete selected frame section. Click OK. Then go to add new properties. Then section shape is concrete rectangular. Click here. First of all, let's define the column here. Generally column size is taken as 12 inch by 12 inch. Material is M25 and depth of the column is 12 inch. Click on enter and width is 12 inch. Click on enter. Here ETABS automatically converts the data into millimeter. Guys, never miss to modify the show rebar. Then click on modify show rebar. Then check on M2 M3 design column. Then longitudinal bar is HYST 500 and confinement bar is HYST 415. Then check this. Then you should check the reinforcement to be designed, not reinforcement to be checked. Then cover for the confinement bar is 40 mm. It's okay. Longitudinal bar along 3 direction is 3. Longitudinal bar along 2 direction is 5. Let's change it. Let's change to the 3. Then longitudinal bar size is generally taken as 12 mm and corner bar size is 16 mm. But this does not make a huge difference in the designing part. Then confinement bar size and area is 8 mm. Then OK. Here it is the rebar area. Here 2 direction is 3 and 3 direction is also 3. Then click on OK. Friends, again add new property. Let's define the beam here. Generally beam size is 14 inch depth by 9 inch width. Material is M20. Depth is 14 inch. Enter. Width is 9 inch. enter. Then go to modify show rebar. Then always check the M3 design only for beam. And longitudinal bar is HYST 500 and confinement bar is 1.5. All the data is rest here. Friends, here is the main difference between the column and beam is reinforcement area. In beam, no reinforcement are shown, but in column, reinforcement are shown. Then click on OK. Click on OK. Then we have to define the slab here. Define, go to define and section properties and click on slab section, and here modifying the slab, that is go to modify show properties. Slab 5 inch. Generally thickness of the slab is taken as 5 inch. Then slab material is taken as M20 and thickness is given as 5 inch. It automatically change in millimeter. Click on OK. Click on OK. Friends, then go to define and define the diaphragm. Diaphragm is the lateral load resisting system from which lateral load is transferred to the vertical column. So here let's add the diaphragm. Diaphragm rigidity is taken as rigid. Click on OK and add new diaphragm. Then D3, then D4. Here I have the building which has 4 slabs. So here D1, D2, D3 and D4 is defined. Click on OK. Now friends, let's define the load pattern. For that, go to define and click on load patterns. There are various types of loads in the building: dead load, live load, partition wall load, staircase load, earthquake load and so on. Here first of all, defining the dead load. Type is dead. Here self weight multiplier for the dead load is 1 because ETABS itself takes the load from the building. Then define the live load. Here self weight multiplier of the live load is 0 because we have to give the value of the live load. Then define the wall load. Then type of the wall load is super dead and self multiplier is 0. Then add new load. Then add partition wall load and type is super dead and add new load. And let's define the floor finish. Type is super dead, add new load. Now defining the staircase load. Type is super dead. Click on add new load. Then friends, let's define the earthquake load. EQX in X direction. Type of the earthquake load is seismic. Self weight multiplier is 0. Here main thing is auto lateral load. It is defined only in earthquake load. Here we take IS 1893 2002. Click on add new load. Then earthquake load in Y direction. Click on add new load. Here friends, never miss to modify the lateral load in earthquake. So first of all, modify lateral load to the earthquake load in X direction. Click on modify lateral load. And for the earthquake load in X direction, let's uncheck the value in Y direction. Here eccentricity is 5%. It's okay. And story range is base to story 4. It's okay. Now response reduction factor is taken as 5. It is from the IS 1893 2002. Let's open it. Here response reduction factor for building system, it is the residential building, so it is special RC moment resisting frame SMRF, so it has the value 5 response reduction factor. So here I take the response reduction factor 5. Then seismic zone factor Z, from the code it is taken as 0.36 for the 5th zone. Let's open it. Okay, here for the 5th zone of seismic zone, very severe zone, the value of the seismic zone factor is 0.36. Let's take site type is second. Site type is also called as soil type. Type second is the medium type of soil. I assumed here medium type of soil. And let's take importance factor I equals to 1, because from the code importance factor for the residential building is 1, all other building have 1.5. so here I take the importance factor is 1. Then for the time period, friends, you can use the time period formula from IS code, that is fundamental time period is TA equals to 0.075 into height to the raised to the power 0.75, where h is the height of building in meter. This excludes the basement stories. So it is the empirical formula which does not give the accurate time period. So I prefer here program calculated value. Then click on OK. Then go to earthquake load in Y direction as well. Then go to modify lateral load. Let's uncheck the value in X direction. Here eccentricity is 5%, it's okay. All of the value here is okay. Then click on OK. Here the friends, these are the loads here I have defined. So this is the load patterns of the building, and then click on OK. Friends, next part is defining the mass source. For that, go to define and click on mass source. Then go to modify show mass source. Then uncheck the element self mass and check the specify load patterns. Here mass multiplier for the dead load is 1. Then live load, I take the mass multiplier is 0.25, that is 25%. 25% of the mass multiplier is taken when the live load is less than or equal to 3 kilonewton. I take mass multiplier is 25% for the live load. If the live load is greater than 3 kilonewton, then mass multiplier is taken as 0.5, that is 50%. Here our building is residential building, so live load is less than or equal to 3 in the residential building. Click on add, and wall load, that is 1, and partition wall load mass multiplier is 1, and floor finish mass multiplier is 1, and staircase load mass multiplier is 1. But never give the mass multiplier for the earthquake load. Then click on OK. Then click on OK. Guys, next part is drawing part. Now I draw the beam, column and slab. First of all, let's draw the beam. Then go to beam icon, then click here, then change the property, that is beam 14 inch by 9 inch. Then go to story 1, The simple method to draw the beam is like this. Select the all grid here and click on it. Okay. Then go to next story. The another method to draw the beam is like this, but this is the very quickest method. Go to next story, select all and go to story 4, select all. Okay, then finish the drawing beam. Now let's draw the column. Go to column icon, click here and change the property here, column 12 inch by 12 inch. There are various methods to draw the column. First method is click on joint here, but the simple method is select the all frames here. It automatically draws the column. Go to next floor, select all grids here, go to next floor, select this, then do like this. Okay, then let's draw the slab. Go to slab icon, change the property to slab 5 inch. There are various methods to draw the slabs. First method is click inside the frame here. Okay, for the next method is select here and draw like this. Okay friends, for the staircase void, let's delete the slab. Okay, this void is for staircase. After that guys, we have to provide the support here. Then for the support, go to base and select the all frames here and go to assign and go to join, go to restraints. Here our support is fixed support, so click on fix support, then click on apply, then okay. Now guys, we have to assign the various types of load in this frame. There are mainly two types of load. The first is frame load and second is cell load. First of all, go to assign and go to frame loads and click on distributed here. First of all, let's assign the wall load. Then go to our AutoCAD buildings. Here there are mainly two types of load. One is outer wall and rest is interior wall. Here outer wall is 9 inch wall and interior wall is 4 inch wall. So for the 9 inch wall, the uniform load is calculated as 12.77, but in our drawing there is opening in the outer wall, so we have to deduct the opening here. Let's deduct the opening 20 to 30%, then value is calculated as 9 kilonewton meter. Okay, let's select the all frames here. These are the outer frames. Click on apply. For the interior wall, go to the drawing. Here are the interior wall in which all the walls have openings. So the value for the interior wall is calculated as 4.5. Then select all interior wall. Click on apply. Okay. Here in this frame, no wall is provided in the drawing. Then go to next story, then click on outer wall, give the value as 9. For interior wall, give the value 4.5. Then here it is parapet wall. The load for parapet wall is calculated as 3 kilonewton meter. Then click on apply and go to next. Click, then give the value 9. Okay, this is the interior wall. The value is 4.5 kilonewton. This is the parapet wall and the value is 3. This is the roof floor. In roof floor only parapet wall. Select all outer. Then go to apply. Click on OK. After that, let's assign the cell load. For that, go to assign and go to cell load and go to uniform. Here first we define the live load. Go to live load. According to IS 875 part 2 code, the live load for the residential building is taken as 2 to 3. Here I take 2. 3 is taken for the lobby and staircase. Here go to select the slab. Click on apply. Go to next floor. Select all slab. Click on apply. Go to next floor. This is the roof floor. Live load for the roof floor is taken as 1.5 kilonewton. Then select here. Click on apply. Then click OK. Then for the floor finish load, go to assign and go to cell load and go to uniform. Then go to floor finish. Floor finish load is generally taken as 1 to 1.5. Here I take 1. OK. Select all the slab here. Click on apply. Click on apply. Go to next floor. Click on apply. OK. Now assigning the partition wall load for the building. Go to assign and go to cell loads. Go to uniform. Then go to partition wall load. Here go to AutoCAD drawing. Here partition wall load is in this slab and in this slab here. So we have to define the partition wall load for this slab and this slab. Okay, the partition wall load is generally calculated by volume and multiply with unit weight, then divided the value by floor area. Here I have already calculated the value, that is nearly equal to 2. So in this slab and in this slab, here partition wall load is partition wall load is provided in this slab and in this slab. So select this slab. Okay, click apply and go to next floor. Okay, then click apply. then click on OK. Now at last friend, let's define the staircase load. Staircase load is rest on this frame and this frame. So go to assign and go to frame loads and go to distributed and select staircase load. Staircase load is generally calculated as 10 to 12 kilonewton, or you may calculate the staircase load, or you may actually calculate the staircase load. Here I take the value 10 kilonewton per meter. So let's assign this value. Here select this frame and this frame, click on apply, go to next floor. Okay, select this frame and this frame, apply, then go to next story. Here in this story, this frame only takes the staircase load, click on apply, then click OK. So this is the load assignment part. Friends, next part is assigning the diaphragm. For that, go to assign and go to joint and click on diaphragms. Here select the diaphragm D1 and then select this frame and click apply, then go to next story, then select D2, apply, then go to next, select this, apply, and go to roof floor, select Defoe, apply, OK. Diaphragm is the lateral load resisting point from which load is transferred to the vertical columns. Click on OK. Then next part is assigning the mesh. For that, go to assign and click on cell, then go to floor auto mesh option. Here meshing is done for proper transferring the loads of the slab into the frames. Mesh is the net-like structure in the slab from which load is easily transferred to the frames into a small portion. Here let's check the mesh object into 2x2 or 3x3. Applies for 3 or 4 noded objects only with no curve edge. Here I prefer the value 3x3. OK. For assigning the mesh, let's select the slab here, then click on apply, go to next story, select it, click on apply, go to next story, click on apply, go to next story, click on apply. OK friends, here it is not the slab, so mesh is not required here. Click on OK. Guys, after this, the next part is defining the load combination. For that, go to define and go to load combination. Then go to add default design combo. Click here and select concrete frame design and select here convert to user combination editable. Check this and click on OK. Here are the 14 combination of the load. The UDCON 2, here we have to modify UDCON 2 as the 1.5 dead load plus live load. Select this and click on modify show combo. Here the scale factor is 1.5, so let's edit it 1.5, that is dead load plus live load plus wall load plus partition wall load plus floor finish plus staircase load OK. Then click on OK. Then click on OK. Okay friends, the last part in the modeling is checking the model, whether there is any error or not in the model of the building. For that, go to Analyze and check the model. Select all, then click on OK. Here model has been checked. No warning message were generated. So our model is fine because there is no error in the model. If there is any error in the model, then warning message were generated, such as if we overlap the frames, then error is obtained. So here there is no any error in the modeling. Okay, let's close it. Okay guys, this is all about the modeling part of the building. The next two part is analysis part and designing part. These two parts will be discussed in my next videos. For then, guys, keep on watching my videos and never miss to subscribe the channel. Thank you.